Hi everyone, hi Mrs. Barrow. My name is Dulak and I'm going to present you a little video as part of my empirical finance class. The subject I have chosen is the instrumental variable technique, which is often used in econometrics in the case of endogenous variables.
Concerning the content of the presentation, I am going to begin with an example in international finance. Afterwards, I am going to introduce the IV technique from a theoretical point of view. I will make comparison with the paper I chose and then go into details, talking about the conditions of a good IV, the Haussmann test to measure endogeneity, and the two-stage least square estimation method. I will then talk about weak instruments problem, which is a key issue using IVs, and I will finish with the limitations of the IV technique. First of all, let us begin with an example. This one comes from a paper of J.A. Jordan and has as topic the impact of intra-industry FDI spillovers on Mexican-owned industry share productivity. Roughly speaking, it aims to assess whether foreign direct investment enhances or not productivity of local firms. The dependent variable is the productivity of Mexican-owned firms. It is explained by a few control variables and by the variable of interest, which is here the intra-industry foreign participation. The different individuals represent the different industries. We could estimate this regression using OLS estimators, but our results would be biased. Indeed, many authors claim that the foreign-owned firms are assumed to gravitate towards high productivity industries, which is a case of reverse causation. Therefore, the OLS would not reflect causality between the dependent variable and the variable of interest, since there are other factors to take into account included in the unobserved characteristics in the error term. That way, we can say that the intra-industry foreign participation variable suffers from endogeneity. Let us now turn to the instrumental variable technique. This method is actually a solution to our previous problem, since it deals with endogenous variables. As its name suggests, it is based on the use of instruments, which are variables used to isolate the good variation of the endogenous variable. In other words, its exogenous part. We will now describe them in more details. For that, let us consider a basic regression, with x1 being an exogenous variable and x2 being an endogenous variable. For the sake of convenience, we will assume that there is no intercept. To help us finding good estimators for this regression, we need the moment conditions to be satisfied. However, because x2 is endogenous, the second condition cannot be respected. The solution to this is to take into account another system of equation, where an instrument of x2, here z2, can make the second equation equal to 0. The instrument is thus uncorrelated with the error term, which corresponds to the exclusion condition. Thanks to this new system of equation, we can find the value of the IV estimator. To be able to calculate it, the identification of the model and consistency of the estimator require that the matrix here is finite and invertible, so that the moment conditions uniquely identify the parameters of interest. For that to be possible, the partial correlation between x2 and z2 cannot be equal to 0. This is called the relevance condition. If the instrument satisfies both conditions, it is said to be a valid instrument. After this theoretical explanation, let us now get back to our previous example for a few seconds. The instrument the author decided to use in his paper for the intra-industry foreign participation variable is the average level of foreign participation in US manufacturing industries. Let us check if this instrument satisfies the two conditions. As a reminder, the relevance condition requires that the partial correlation between the instrument and the endogenous variable does not equal 0. The advantage of this condition is that it can be tested through a regression of the endogenous variable on the exogenous variable and the instrument, called first-stage regression. In our example, the author used this test and concluded that the association between the endogenous variable and its instrument to be significant at the 1% level, which is actually not that surprising, since that there appears to exist a worldwide difference in FDI intensity between industries. The exclusion condition, for its part, requires the correlation between the instrument and the error term to be zero. Unfortunately, it is not testable, due to the fact that the error term is unobservable. The assumption, therefore, needs to be defended from an economic point of view. Concerning our example, this is what the author did. He gave some arguments to defend the fact that foreign participation in US industries cannot be endogenous, like the fact that FDI from third countries into the US and Mexico are pretty related, and the fact that the amount of Mexican outward FDI to the US is quite small. Because it satisfies both conditions, we can conclude that this instrument can be considered as valid. Next, the Hausman test allows us to test the endogeneity of X2, but only if we make the assumption that our instrument is valid. Its goal is actually to compare the OLS and the IV estimators using the estimation of the residuals from the first stage regression. The test consists of adding them in the basic regression and to test their significance. They must be significant for X2 to actually be endogenous, otherwise it is considered exogenous. Now, let's take a look at the two-stage least squared method, which is the extension of the OLS method in the case of instrumental variables. As its name suggests, this method is composed by two stages. First, we need to run the first stage regression, whose name seems more obvious now, in order to create a new variable, which corresponds to the estimated value of X2, and which is here X hat 2. Secondly, we use the model estimated values from stage 1 in place of the actual values of the endogenous variable in the basic regression in order to be able to estimate it with OLS estimators. That way, we isolate the good variation and get rid of the bad variation. When both relevance and exclusion conditions are satisfied, the 2SLS yields consistent estimates for all the betas. A problem that needs to be addressed as part of the IV technique is the weak instruments problem. Indeed, the IV estimator can be biased if the instrument and the endogenous variable are only weakly correlated. Hahn and Hausman give an approximation of the bias of 2SLS for a finite sample, based on the number of instruments, the correlation between the endogenous variable and its instrument, the R-squared of the first stage regression, and the sample size. In order to detect if we are in presence of such weak instruments, the most obvious clue is large standard errors, since the variance of an IV estimator depends inversely on the covariance between the endogenous variable and the instrument. Another way consists of computing the F statistics based on the first stage regression. If it is lower than 10, the instrument can be considered as weak. In our example, the author did not need to worry about weak instruments problem, since he obtained an F statistic of 14. To conclude this presentation, I am going to summarize the main limitations of the IV technique. The first problem that we should be aware of is that it is far from obvious to find a good and valid instrument, since even the best ones are sometimes found to violate the exclusion restriction. Subsequently, we need to take into account the possibility of weak instruments, which can be a problem, particularly when there are more instruments than problematic regressors, which we actually have not seen in these presentations since we limited ourselves to the basic case with one endogenous variable and one instrument. Thank you very much for your attention. I hope you enjoyed this presentation.